Hi, everybody. As promised, I'm recording a lecture that will cover the process and techniques for assignment M1A2, the tree grove, really a laser cutter primer, basically, that we're going to be working on. So let's get started. I guess the first thing is, what is a laser cutter? We have 4 of them within the building now, and you'll be using them frequently, I would say, over the next few years of your time here in the program. And basically, it's an efficient tool for rapid manufacturing of flat parts. Cuts geometry from two-dimensional CAD files or Illustrator files, anything that has vector information in it, out of different types of chipboard, wood, and thermoplastic-based materials. So what it's really good for, obviously we can do that with X-Acto knives and straight edges, but the laser cutter is faster, and it's also really good for particularly intricate shapes with sharp corners. If you've ever tried to cut chipboard, even with a sharp X-Acto knife, you know that once you start getting into tight turns and corners, it gets really difficult to keep it sharp and the cuts crisp. So it really aids in creating quick prototypes. There's certainly a little bit of upfront time to prepare the files to get everything set up, but once you do, then you can just let the laser cutter go. And as I mentioned, it's really, you can create three-dimensional shapes from assembled 2D components. As you see in the little image of the Hummer car down there, it's really just assembled from a series of flat parts. Even the wheels, which are round and roll, are created by just gluing a bunch of circles together to create that shape. So you do have to start thinking about, if you start to do more complex 3D shapes, we can take 3D models, we can unfold them, we can assemble them like the wheels and the tires I was just talking about by gluing them up in layers. There's a couple different ways to approach that. We're not going to get into all those methods right now. The intent of this exercise is to just give you a primer, an introduction to the laser cutter, and later on in the semester you'll be using it to help you create models in your design studio. Basically, the components that we're going to cover are how to set up and use a laser cutter to cut, which means cutting all the way through, to score, which means to cut partially through, enough, for example, that you could fold it or bend the chipboard around a corner without tearing it. And then vector engrave, which is really a very light cut on the surface just to create a surface pattern. And raster engrave either uses a raster image, like the kind we work on in Photoshop, a grayscale image, or in some cases, for example, in AutoCAD, if you're using text and you don't explode it, it gets cut as a raster engrave process. And I'll show examples of that and explain that more. I actually have some videos of showing how the laser cutter performs each of those different acts. And basically, we'll go through and explain how to create the shapes you need, how to get them into AutoCAD, how to set them up on layers so that you can communicate to the laser cutter how it needs to work, whether it needs to cut, score, or engrave. So laser just means, it's an acronym for light amplification by stimulated emission of radiation. And basically, as you know, it heats a very small area on a material to extremely high temperature in a short time, and basically causing it to melt, burn, or vaporize. And you can see in the example on the right there, whether it's a score line or a cut through, like is in the circles there, there is some singeing around the corners because that's what you're doing. And since it's very, very thin, you can cut very precisely or do very light scoring and engraving, depending on the way, how you have the laser cutter set up and what kind of settings you use in the print dialog box, which we'll get to in a little bit. But basically, the fact that you are melting, burning, or vaporizing material means that safety is an issue, because there's a fine line between cutting through something and catching it on fire. So that's why there is a process about how you get access to one of these laser cutters. And you will have to complete an online safety certificate, and you will also have a training session with Jamie Heilman. He is the gentleman who takes care of all things to do with digital fabrication in the school, and he is the expert. So anything that you hear from me in this presentation, I'll be honest, I haven't had time, since the computers have just got set up at the end of the summer, to actually go through this on the new setup with the laser cutter. So this is based on the procedure from last year. I assume they're going to be pretty much the same, but anything he tells you will supersede anything you hear in this presentation. He's the one that keeps things running. There may be up-to-date drivers, there may be some other slight variations. So I'll be going over a lot of information in here that he will cover in the training session, just so you kind of have an idea what you're going to be needing to know. But his instruction is really kind of the thing that's going to show you the full nuts and bolts and how to make these things work. So it's not just how you cut something out, it's how you care for them, clean them, safety procedures that are involved, what to do if something goes wrong, all that kind of stuff. Basically, once you've been trained on this, then you can sign up in 1-hour sessions, 1-hour time slots. And we do that to make sure everybody has a chance to have equal access to the laser cutters. And so it becomes important to know, and we'll talk about this in a little bit, how long the job you're going to send takes, because you will only have an hour. When your hour's up, you've got to stop because somebody else is next in line. There is a fee for using laser cutters. I believe there may be a certain amount of time up front that you get for free, and then after that, basically it's an hourly charge for the time that you spend. You will buy your own materials, and Jamie has those down in the DigiFab lab as well, which is really helpful. We'll talk about that in a second. But you will need your ID in order to use these when you go up there. So keep that in mind. He'll explain all that and tell you what the rates are when he has you in the training sessions. So what can you cut with? And again, Jamie will provide you with a complete list of materials because there are a few things you have to be careful with. But basically, chipboard, thin wood, acrylic up to a 1/4 inch thick. Acrylic's kind of the critical one. There are certain kinds of acrylics that just melt, which makes a mess of the laser cutter. So I would say, never buy anything and bring it in to use without checking with Jamie. And in fact, as I mentioned, he stocks a lot of this stuff downstairs. I've seen students coming up from the basement already carrying material this year. And you could buy it to use for other stuff. You don't have to use it in the laser cutter, but anything he sells down there is appropriate. So that's kind of your best source. The largest sheet size these laser cutters can take is 18 inches by 32 inches. So you have to be able to figure out how to break things down within that overall sheet size in order to create larger assemblies if you need to do that. So if you're creating a bigger model, you might have to cut it into quarters or something so you can do it one section at a time. Okay, the tree grove, the point of this exercise, M1A2. As I mentioned, this is actually kind of a downsize from what we've been doing the last few years, and you may or may not have heard we did something called last lanterns, and I think I have a couple close-up pictures of one, and I'll bring one to class on Tuesday. But it was a fun project. We often used them for centerpieces at the awards banquet at the end of the year, but for the amount of points that it was worth, it was actually quite a bit of work, although I think everybody enjoyed doing it. And it certainly got you familiar with how to use the laser cutter. So just because we're introducing a couple other new things this year, and also in a way in preparation for next year, in which 251 will be taught in a totally different way as a kind of parallel course to the studio, much more integrated with what's happening in the design studio itself. So we decided this year to just do this kind of primer exercise where essentially we'll let you use either use some of your tree blocks in elevation that you already created for the first exercise, or if you want to create another one, that's up to you. But we're going to have you set those up so you can cut those out in the laser cutter and then turn them into 3-dimensional style trees. Actually, we're going to have one as 2-dimension, and then you're going to have two as 3-dimensional, and include a couple of your people for scale. And we're just going to have you cut that out of chipboard, as you see here in these examples. But they need to be able to stand up and be connected to a base, which we'll provide in the template, the AutoCAD template. Actually, I think we use the same base as we used last year for the last lanterns, just you'll be able to mount them right on top of that so that they can stand up. And who knows, maybe they'll use some of these for centerpieces at the awards banquet anyway, but this will be a lot less trouble because you can use something you already have. Basically, you can set up one of these trees to be cut and then copy and paste it, and so it's going to take you a lot less time to work through it. But we do want you to think about a little basic, simple composition, and we'll talk about that in class. So in terms of preparing for this, the first thing obviously is designing your tree grove. You have to select your tree forms or your elevations, and as I said, you can, if you find something else that you want to use or you want to modify one of the elevation trees that you have, that's fine. The design composition and the arrangement of them is going to be pretty basic. Like I said, a minimum of 3. One is 2-dimensional and 2 are 3-dimensional. So you're going to have to take that one 2D form and repeat it or interlock it somehow, like you see here on the right, to create a form that looks more 3-dimensional. There's also some students in the past have used another method where they actually scored some of the branches so that they could bend and fold in different directions. So you could have actually like two layers of chipboard, and then on one side a branch folds out one way, and the other side it folds out the other way, so that it creates a more three-dimensional look. How you do that is up to you, and we can discuss that with you in class as well. We want you to make sure you have some detail with vector and raster etching. In this one, mainly vector etching for the trees. So if you have a branching tree, maybe where on some of the branches you can actually put some lines on there to create like a bark texture, which you may not have in your existing elevation, but for this exercise, we want you to demonstrate the use of that method so that we know you understand how to set things up for it. And then finally, you just have to figure out how to hook it to the base. You can see these trunks are kind of flared out so that you could just glue that down, and that would be certainly very stable. You could also kind of design a hole or openings in the base so that your trees can slide into those slots, and so you can still glue them, but at least there'll be a little extra attachment there. Or you could even cut and score tabs on the base so that they can fold up, and then you could slide the tree down in between there and glue it, so it's kind of like an extra little footing or foundation for it. Doesn't matter how you do it, as long as it looks clean, it's well crafted, and it's strong, and the trees aren't going to fall over. Okay, the next few sections here, I'm giving you for information, and I'm not even going to run through all the stuff. This was very applicable to the last lanterns because they were much more complex, but it's also really, these are some really great techniques that you should just be aware of. So in the future, if you want to try and make some more complex forms, you understand how to use these. So if you were going from a raster-based image or a sketch, you could start in Photoshop. In this case, we were doing compositions that had figure-ground relationships, and so it was really hard in AutoCAD to understand what was solid and what was open. So in Photoshop, you could go in and fill it in. It's very easy, as you can see here, to tell what's solid, what's void. Then, as you'll see in the next slide, we actually could bring that into Illustrator and turn it into vectors. So I'll spend a little more time talking about that just so you're aware of it, but that's something we can use Photoshop for. You don't need to do that for this exercise. Basically, it's not that complex. You've got the trees. You could go in AutoCAD and fill the trunks with hatching so that in AutoCAD you can see what's solid and what's not. That would be a good way to do it, just to make sure you really can pre-visualize what the tree is going to look like once it's cut out. And then before you go send it to the LaserCutter, just get rid of the hatching so that it's open. So we can help you with that as well. Illustrator actually has some really cool functions, and you'd probably be wishing I had told you this before. You did your block files, at least your elevation ones, which you had to sit there and either draw from scratch or trace over. And I will, when I flip to the next slide, there's actually a movie. I'm not going to let the movie play through. It's another screen recording with my voice in it. So I'm not going to run that through in this lecture because you really don't necessarily need to do that unless you want to find another tree, another image that's more decorative than the ones you created. This following method would give you a really quick way to create that. So anyone who's interested, two things. One, I can help you with it. We can help you with it in class. And two, I will post a link to this Prezi. It won't be narrated, but those movies already are narrated. So you could go to those movies and sit and watch them and figure out the technique from there. It runs through it. But basically it allows you to go from a raster-based image like this in Photoshop to bring it into Illustrator. And Illustrator has an image trace function, so it turns that raster into a series of vectors. So this is ready to go into AutoCAD. I didn't trace one thing by hand. I had made this in Photoshop, or if you scan something in that was black and white or found an image online, you bring it into Illustrator, adjust some settings, and next thing it's cranked out the exact outlines in vectors. And as I said, this movie
image and convert it into vectors that you can then export as an AutoCAD.
It goes through the whole process of how you go from Photoshop or from a raster image into Illustrator, turn that into a vector, export it as an AutoCAD file. So if you're interested in doing that, ask me about it, or just for future reference, it gives you a really quick way to convert raster to vector without having to trace over everything. Okay, the real workhorse in this process is AutoCAD. That's where we're going to set up this, these elements, these pieces that we're going to cut out. That's the software we're going to use to actually send the information to the LaserCutter. That's what controls it. That's where the I'll call them printer drivers are, because basically the laser cutter is like a three-dimensional printer. It's sending the same kind of information, but instead of creating the forms with ink or toner, it's doing it with lasers. So you'll see when I show you the movies of that how similar it looks to actually just printing something and using ink. So you'll be importing your image, well, not images probably in this case, your vectors, your blocks, or whatever you're using to create this tree, if you create a new one, into AutoCAD. And we're actually going to give you a template that has the basic layers set up and a border that, that's drawn at 18 by 32 inches. So you know everything you're going to put into this process has to fit within those boundaries. And you'll notice on the screen image below, you can't see the detail, but there's different colors. And so blue is generally standard for cut. Green is score, which is cut on a low setting. Red is vector engraving. So that just creates a surface line, but it doesn't burn all the way through. Black is raster engraving if you're using images or non-exploded text. And then we have a layer for non-plot. So any guidelines you have in there, the border for the 18 by 32 inch sheet, we don't really need to have it try and cut that out. So you can see it, but it's on a non-plot layer, which means the laser cutter will ignore it. So a few things in AutoCAD, and I'll come back to this when I show you the movies of the laser cutter in action. But the first thing is avoid double lines. Sometimes whether it's through the image trace function in Illustrator, or if you drew something else and there's a sidewalk line and a paving and a ground cover or lawn edge or something else, you really want to get rid of duplicate lines before you send things to LaserCutter, because it doesn't care if they're right in the same place. If it sees them, it will send the LaserCutter to that path as many times as there are lines. So once it's cut through the first time, it's going to go back and it's going to cut through another time, even though there's nothing to cut anymore because it's already done it. And I actually have an example of that you'll be able to see. So it just means it makes your cutting time more efficient. Also, another technique is to join the polygons before cutting. Not have them exploded down to just lines, because when it's a polyline, the laser cutter will follow along that path more consistently. Instead of jumping around from one to the other, it just speeds things up. So if you have a bunch of of separated lines that can be joined in a polygon, that's a really good thing to do before you send it to the laser cutter. I mean, laser cutter. So anyway, the other thing is really important, and we've been kind of going back and forth with how to set attributes on objects. So in this case, you must set all object attributes to by layer. We don't want anything assigned to an object itself. Like, you don't want to go in the properties and just say, okay, I want this line weight, this color. We want everything to be set by layer. Then we have layers set up for those different operations: cut, score, vector engrave, raster engrave, right? So that's the first thing. You want to make sure it's set up that way. And you may or may not have your current elevation blocks set up that way. You may have assigned things, so you're going to have to back and change that before you send it to the laser cutter. Secondly, all vector layers have to be set to 0.00 line weight. Anything above that, above 0, will be raster engraved, which is way slower than vector engraving or cutting. Okay, it sees it as a raster image if it has a line weight. It says, oh, well, they're telling me I want this to be 0.5 millimeters thick. Therefore, I have to do that by just lightly going over it to create that thickness. As opposed to, if the line weight's 0, I just cut through it. So those two things are really important. All attributes set by layer, and all layers set to 0 line weight. And if you want text to be cut out like vectors, and there's a little movie that'll follow, you can see the edge of it on the screen there, you have to explode it. And again, I'm not going to run through that movie. It's got my voice on it. You can look at it when you want. But in this case, we actually want you to put your name and the course information on the base. And you can do that with regular text and not explode it. And therefore, it will raster engrave it. That way you can see the difference between the different functions. And that's the point of this exercise. We just want you to get familiar with all the functions and how the way you set it up affects how the laser cutter performs. Okay, so there's some information about creating regions, exploding text, doing all that, and actually this movie here.
Text explode command to.
We'll go through it and explain how to do that. So basically it takes any kind of regular text and it explodes it into lines. So now it's just geometry like everything else in there, which means you could put it on a vector engraving layer, you could put it on a cut layer, score layer, however you want to do it. So if you're interested in this, look at the link to the Prezi, come back and take a look at it. I'm not going to run through it now. Okay, the cutting process. This isn't really, well, it is kind of an issue for this. And I don't know if this is still, David mentioned the other day, we weren't sure we were getting the same watermark on the educational version. But if you use an educational version on your own computer and it gets on your file, it's this thing right down here. The problem with this is it puts it out at the edges of the plot. And because it's regular text and you don't have any control over it, you can't explode it or delete it. It's there. It puts it in at the end. The laser cutter has to go back and forth the entire way across the 18 by 32 inch piece of paper and raster engrave produced by an Autodesk educational product. So just that alone takes an enormous amount of time because it has to go all the way from one side to the other just to do those letters on each side. So after a little searching online, I found a process that you can actually open your tree growth file or any file that you're ready to cut in AutoCAD, save it as a DXF, close the file window, but don't quit AutoCAD. Then you open that DXF file in a second instance of AutoCAD. And then when you plot that, the plot stamp won't be on it. So it's not a problem with this exercise. It's a problem for everybody that uses the educational version. So it seemed to work fine last year. I don't know if we're going to get the same issue this year, but just refer back to this if you're having that problem. It's not that you can't do it with the plot stamp on there. It just means it's going to take a lot longer because you're raster engraving some information that you don't really care about. Okay, when you plot to the laser cutter, and that's basically what it is, you use the same plot command. Instead of going to a printer, you go to the laser cutter. And we're going to plot from model space. We'll talk more about layout paper space later on, but here we're just going to plot right from model space since it's real world scale, 18 by 32 inches. We select the laser cutter from the printer plotter list, set up the properties, save a temp file, and when we choose what to plot, we're going to use this window method. And I'll demonstrate that. Well, I won't demonstrate it in class, but Jamie can demonstrate it when he has you doing the training at the laser cutters themselves. And then you plot the file. So this next series of images you can look at. Basically, when you pull this up, you'll notice under printer plotter, it says, whatever laser cutter number 4, use this one. That's a plot file that's set up for the laser cutter. And that's what you want to choose, not PDF, not a printer. You want to choose the laser cutter. Then we'll just say, yeah, use default paper size. It's just kind of dialogues you need to go through as it runs through. Then we'll go to custom properties, click on custom properties, and we'll see this kind of dialogue. So this is the setup that controls the laser cutter from AutoCAD based on the way your drawing is organized by layers and colors. Now this is kind of an empty generic file here. Unfortunately, you can click the load button, and when you do so, Jamie already has a bunch of plot configurations set up. So you can see right here where we said on this exercise you're going to use 2-ply chipboard. So you load in this configuration file, engraver settings, you choose 2-ply chipboard, click open, and it will come back to here, and you can see now it's got the sliders have changed. So when I mentioned there's a black layer for raster, see it's 20% power, 100% speed. Red is the vector etching, so it's 10% power, you want less power, and 50% speed. Green is for scoring, I think or cutting. I mean, these really can be set up for anything, but that's the way this is. That's basically a cutting layer, and you can see here the blue is one we usually use, the layer set up for blue, 30% power, 15% speed. So you control what happens. You can reset any of these you want because basically how much power, how much speed, and you want to have it work as fast as possible, get the cutting result that you want, and not catch your stuff on fire. And you'll see in the movies in a second how the flame gets up, and I have caught a couple things on fire because if you get a lot of detail in the same area, even though it's fast, the material keeps heating up and heating up and heating up, and then sooner or later it's going to burst into flames. So use these default settings. That's another advantage of buying chipboard from Jamie. I think he's got these customized to work with the materials that he has. When we did the last lanterns last year, we used a fancier, not chipboard, but a presentation board, and it had kind of regular chipboard ply inside, but a nice blue finished paper on the outside, a nice blue facing on the outside. So it was much denser, and it was more difficult to get it to score and bend in the right places. So that was more complicated. Plain, standard, generic chipboard works with these settings. So you can just load in the settings for the board you're using, and you should be good to go. But he will explain more about this too. It'll ask you if you want to save the changes. You just apply it to the current plot. And then basically you open the LaserCutter control panel from the desktop, and there is a little application that you can use once you've got this set up. And you can check the cutting time. There's actually a thing that estimates it, so I'll show you an image of that real quick. You put your media inside the LaserCutter, clean the mirrors. It basically has on the arm, it has a LaserCutter on the side, and it shoots it across, and it bounces off a mirror and down onto the surface. So, and then of course you have to close the lid. It won't function unless the lid's open. You turn the exhaust fan on, activate the LaserCutter, and start the job. Now, Jamie's going to go through all these steps with you in great detail, show you exactly how to pull the little mirror out, clean it, all that kind of stuff. So he will go over this. I just wanted to kind of show you the basic steps. And one of the most important things is you don't leave until it's done. Okay, there's always a chance that something's going to catch on fire. Even if you've set everything up right, it can happen. And so you never leave the job while it's going. If you want to do something else while it's cutting, bring a laptop, bring a book, whatever. But you always have to stay there and watch it. Okay. And secondly, pick up after yourself when you're done. You know, you're going to take your finished product. If you have an intricate tree with lots of inner spaces, when you pick it up, you're going to be like, wow, this tree is beautiful. And you're going to leave all these little pieces laying in the LaserCutter. And the next person that comes after you will have to pick all of them out before they can put their sheet of chipboard in there. So clean up after yourself. If they're really little pieces, I think there's a vacuum up there. You can vacuum it out so that it's always ready for the next person, and we don't get stray pieces of scraps and chipboard laying around that could catch on fire accidentally. Okay, this is just a little movie of the desktop app that allows you to open up. You click start for the preview estimated job time. It runs through it on the screen really quickly, and so you can see in this one it's basically 50 minutes and 50 seconds. So for the last lantern, which was much more complicated, that's perfect because you have an hour time slot, right? So if you have something that goes over an hour, you're not going to be able to finish it. Okay, so here's the LaserCutter in action. This is actually raster engraving. It's creating this based on a photograph, and you can see at this leading edge down here, the little sparks are flying, and it's just like an inkjet printer. It's just going back and forth and using lasers to cut into the chipboard in varying depths to try and create actually what looks like shades of gray based on the plies. So you can't get a lot of detail, but you can see this is pretty time consuming because it has to go back and forth and back and forth and back and forth, no matter how much area is here. Okay, so that's raster engraving. That's either from using a black and white image as the source for that, or if you have text in AutoCAD that hasn't been exploded, it will create it the same way. Now watch that, look at this compared to that. So this is this is vector engraving, okay? So it's not cutting through, it's actually just cutting along a surface. And this is some detail where you can see the LaserCutter as you keep going back and forth. I think later on, I don't know if it shows it in this video, but later on, this is kind of where it caught on fire. That little detail in the same area, it keeps going over and over, and it's very close. So you have to watch out for that. You can also see it's kind of jumping around a bit. There's no way to control the exact order of it. But this is why you want as many lines put together as polylines as possible, because it tends to do more continuous ones. Like you see here, it's going to keep going around and around. So anyway, that's vector engraving. So it's cutting through the surface a little bit, but not all the way. Okay, and this is cutting, and you can see pieces are dropping out as it goes through. You can also see the flame is much brighter, and there's a lot more singeing along the edges. Now, some of the pieces fall out, some of them don't, because there's a little mesh grid under there. But and the chipboard isn't laying perfectly flat. Now this one you can watch, you just notice it just went over the same area. It's going to do it again. It's going to come back over. So that's an area where there were two outlines of that shape in the same place that I didn't get rid of. And obviously it didn't take that much more time, but if every one of those shapes had double sets of lines, it would take twice as long to do it. And then you might run out of time within your designated time slot. So be sure you clean that kind of thing up. You just want it to go around one time. That's all it needs to do. And you'll save yourself a lot of time. Okay, then the assembly process. I don't have a picture. I'm sorry. I haven't built one of these myself this year. So I might model one in SketchUp and just show you the kind of the basic idea so you can see it. But that'll be the next step. Once you cut things out, you need to assemble the trees, figure out how to make them stand up and how to attach them to the base. As I mentioned, you could fold up tabs, you could flare the base, you can create openings, so you kind of drop it through the slot and then glue it from underneath. The idea is, do you want the finished product to look nice and neat and sharp on the outside? You want the trees to be stable and not fall over. And if there's any chance of having these used at the banquet in the spring, they need to hold together until April. Okay, so and the model that you're going to create in Studio is going to be way more complex than this. And so just get in the habit of trying to assemble things as carefully and as solidly as you can so that they stay together and they don't fall apart on the way to presentations. Fitting and gluing, just again, think about craft. The base is going to look like this. This is the last lantern. It's going to have a template so everybody can cut it out. It will already be set up for you, but you will have to score these lines and fold and glue it together. So when it's done, it should look like this. It shouldn't be like flared out on one side and big globs of glue dripping off of it. Just make sure that everything is assembled as neatly as possible. Yeah, in this case, you're not inserting the lantern. This top will be solid, and any openings you put in it to help fasten your trees are going to be totally up to you. So I will give you the template for the base for these fold lines, so everybody will have the same size, but you will have to modify the top of it to accommodate your models, however you decide to do that. Okay, so this isn't really what we're expecting of you. This is just one I found online, but it's kind of an interesting thing. It's a different kind of base, and it's very complex. But you can see how much, how much interesting compositions you can create just from a series of flat shapes like this. It's also a great example of just kind of multi-layers of chipboard where you can see different openings, and it creates a certain amount of depth there and interest based on even just several layers of flat cutouts that don't match perfectly. Okay, so that's the basic overview of the LaserCutter. I will post this on YouTube for you, and I will also post a link to the original Prezi so that if you want to watch some of those movies that are embedded in there about how to use Illustrator to do image trace or how to explode text in AutoCAD, you can do that if you want to. But I do want to emphasize that none of those methods are necessary for this exercise. You can use your trees from your block library, figure out how you're going to connect them together. You might have to cut slots in them, draw slots so that you can slide one piece into the other piece in a perpendicular direction. You might do a score line, so you fold it and bend it out, and then do another one and fold it and bend it out and glue them together. So there's a couple different ways you can create three-dimensional form from those two-dimensional cutouts. And we'll be happy to talk with you about that in class tomorrow.